And we are live. Welcome this evening to our live chat as we have every week. We have a couple of topics that we want to talk about. Let me go to here first. There you go. Okay, good. We're back. All right, good. So it looks like everything is working as expected. And yes, this is working good. And very nice. Yeah, okay. So good. We are live and we're ready to roll. So, a couple of things I want to talk about this evening, and I'll take some of your questions in response to the thunderstorm potential for tomorrow and why there might be a hint of some severe weather for tomorrow, especially around the Hudson River Valley. I'll explain why. We'll talk about the pattern overall and what's happening. We'll break down from the stratosphere down to tropical forcing. And of course, there is some new data, some very interesting new data on climate change in relations to hurricanes and precipitation rates. And the reason why I want to touch on that is that, hey, we're heading into tropical hurricane season in a couple months, so it's a good idea to get some of that data and see what they are saying and what is reasonable conclusions and what are not. So first, let's pull up the data here. And we start off first with, before we talk about a severe event, let's get a pretty good idea on what's happening with the atmosphere overall, right? So over the past couple of weeks, we've been talking about the fact that we're moving into spring. We're going to see a stronger influence from the sun, and the sun has been very, very active. I mean, all sorts of interesting impacts here from the sun. And that's leading to an evolution where our ozone buildup is starting to get broken down. Now, the reason why ozone has been really important is that we start off our ozone at a high level, okay, above normal level. So you have all this ozone built up in the northern hemisphere, especially around the polar regions, which was driven by major stratospheric warming around March, which elevated the ozone amount in the stratosphere. So you have this above normal level already in place. And then you introduce the solar impacts that you normally see during spring. And what that leads to is what we're seeing here. We start off with a very impressive warming event. It will start at the beginning, right? And now look what's happening. As the sun is gaining more and more influence, we're starting to see a nice rapid cooling of the stratosphere. And let me refresh this real fast. Because unfortunately the display here is getting a little choppy, which is typical. But the reason why this is important is that it sets the stage for the rest of the atmosphere in terms of the influence with La Nina and how that impacts the polar jet stream and how that impacts our weather, and then how do we get to the weather we're seeing now. So this is all, we're doing a top-down evolution here, so we get a better understanding of what's happening with our atmosphere. So you're seeing this massive cooling starting to take place, and you can see the end point here where we go from this point where we have well above normal temperatures, the sun starts to have an influence, and then now you see this massive cooling taking place. And this is all because the more increase we have of solar activity on the northern hemisphere as we move through spring and summer, the more this ozone is just getting blown up and torn apart. And so when you have this ozone destruction, it leads to cooling in the stratosphere, especially the lower stratosphere. And so as a result, you start to get this whole evolution of impact on the atmosphere as a whole. Meanwhile, let me pull up what's going on with La Nina. And our SOI data, which is what I like to use to measure the strength of La Nina, because this is the atmospheric signals of La Nina. And you can see that the SOI values are between 10 and 13. Why is that important? Well, when we are looking for a strong La Nina, we typically look for values above 25, moderate between 15 and 25, and weak generally below 15. Okay, it's usually a good sign of what we're looking for in the atmosphere in terms of impacts. So this is still a weak La Nina impact. It's getting pretty close to moderate, though, I would say that. And you're seeing in our temperature anomalies pretty much, let's zoom in on this here, pretty much still central to west-based anomalies here. Nino 1+2, which is out here, remains incredibly volatile. Every other day it's bouncing from positive to negative and back again, okay? So you kind of want to stay away from that area in terms of trying to measure what's going on with the incidental event, whether it's La Nina or El Nino. Just kind of put that to the side. And so what you want to look at basically is zones 3 through 4. So right here. And you're seeing right now, you're seeing that strong influence on the tropical Pacific. It's limiting your convection, and it's leading to an impact where you are setting up the potential for stronger upper level lows here, especially in the Gulf of Alaska, because of the negative PDO signal that we're seeing and the thermal gradient setting up here, which, when we consider the wavelengths, leads to a weak ridge here, or should I say a strong ridge here, and a strong ridge here. Combine that with what we're seeing here with the negative AMO. That also supports above normal heights around Florida, which typically means drier weather pattern around Florida, and above normal precipitation along the Gulf Coast, the plains, and the Mid-Atlantic. So basically in this area right here. Now think about this here. You have your tropical forcing in place. So you have your La Nina in place where you have your convection focused mostly around here, which lines up very nicely with what we're seeing with the MJO. So we have that factor in place, which instigates a more enhanced polar jet stream for this time of year, which allows for an upper level low here, which allows for a ridge here, and a ridge around the southeast. That leads to the potential for a better chance for a cutoff low here in the plains up towards the Great Lakes. And that, ladies and gentlemen, means that you have the potential for stronger divergence and diffluence right over here, over the Mid-Atlantic, which translates us to what's going on right now. Ta-da! Pattern look familiar? Ridge trying to build over the west. You got a deep trough over the Pacific Northwest, which is connected to what is going on here in the Pacific with another deep trough around the Aleutians. Below normal heights and a low weak ridge. Meanwhile, you get a nice ridge along the east coast. Upper level low continues to dig, negatively tilted trough, sets up the environment where you have divergence and diffluence here. That's going to be shifting east and setting us up for some showers and thunderstorms. Now notice this upper level low is not going to be able to get towards us. It's going to get cut up towards the St. Lawrence River Valley. We're going to get basically a glancing blow from this upper level low's influence, but just enough to make things interesting for tomorrow. So again, now we've seen what the influence from the top of the stratosphere down to the troposphere into the tropical Pacific and tropical Atlantic. And the stratosphere plays a game in this, in that, let me pull this up, it destabilizes the atmosphere. Let's see here, I got a chart around here somewhere. Here we are. Okay. So let me pull this back here. Okay. This should do it. Okay, so what's happening is through the winter months, you had a very warm stratospheric environment on average. And that led to all sorts of interesting storms, active weather. Here's our unsettled conditions in late February through March. And now we're seeing this cooling. Now, why is this cooling important? Well, as we move through the spring and summer months, this cooling that we're seeing at 100 millibars is already starting to bleed and will continue to bleed into 300 millibars and 500 millibars. And what that does is that it causes instability at the surface at 1000 millibars to be able to interact with this cold air. So you get, let's say, because of this cold air sinking south, it leads to, or lower in the atmosphere, it leads to compression at 500 millibars and 1000 millibars. That compression leads to above normal 500 millibar heights. The 500 millibar heights allows for greater heat to develop. The heat, or the above normal temperatures at the surface, starts to interact because your warmer parcels in the atmosphere is able to rise faster. It rises until it reaches this cold point. With this very cold air in the upper troposphere and lower stratosphere, it leads to faster rising motion and more dynamic thunderstorms. So now you can see this whole environment starting to take shape here. Now replace this cold area with above normal temperatures over North America, specifically over the eastern United States. Throw in some tropical moisture, and voila, you get your thunderstorm outbreaks. And that, ladies and gentlemen, is what we're starting to see here. It all combines into what we're seeing here at the surface. Let me just move this here real fast. Okay, so you can see really clearly here this line of thunderstorms and this setup here. And clearly we have an unstable environment here with enough turning in the atmosphere to produce severe thunderstorms and a few tornadoes. Now, this turning here is driven by our jet streak here. Notice all our turning is happening right where you're seeing this strong divergence and diffluence. Take a look at 850 millibars. We'll zoom in. Bring this into HD. And there's our jet streak, setting up the severe weather. And you can see the convergence here with the winds and the vertical wind shear associated here. Lines up perfectly with our severe thunderstorm event. Now, this environment is not going to be reaching us. So how do we have a potential for severe thunderstorms? Well, let's take a look at some of the guidance here. Now, this is the NAM guidance here. And you can see that it's suggesting a nice line of showers and thunderstorms for tomorrow afternoon and just in time for the rush hour. Of course, it would be right around the rush hour because, why not make it more difficult to get home, right? So this line is coming through and the SPC increased the potential for severe thunderstorms right around the northern mid-Atlantic and in the New York City metro, basically from the I-95 corridor on to the northwest. So why did it do that? Where's the support for that? Well, it comes down to what we're seeing here in the model guidance with the 150 millibar winds during that time period. You see this evolution right here? This evolution right here? This is leading to a very strong jet streak taking place. And this crashing here of the winds at this level could support enough turning to support an isolated severe thunderstorm. Now, I think this is going to be a very isolated potential here in terms of severe weather. But if it is going to happen, it's going to happen in the Hudson River Valley where you see this jet streak. Because lower towards like the Philadelphia metro and Delaware River Valley, the winds are not as strong. You're not seeing as strong a vertical wind shear. What I will be keeping an eye on is, let me see if I have it in here, the precipitable water values. Here we go. Perfect. Because the precipitable water values at this point are up to about 1.8 inches. So this would all signal the potential for a line of showers and thunderstorms, very heavy downpours. Wouldn't be surprised to see vivid lightning. The more moisture we have in the atmosphere, the more vivid the lightning. And the more enhanced our precipitable water values are, the better potential for an enhancement of our thunderstorms. And it also increases the potential for some hail and downburst wind gusts. And downburst wind gusts are driven by all the deep moisture at the surface being lifted up into the mid-levels of the atmosphere where it's colder. That moist air cools rapidly and sinks like a rock. That's how you get your downburst wind gusts. So it slams down onto the surface. So that's another way where you could end up with an isolated severe thunderstorm. I don't see this as being a tornadic threat. I do see this as being a strong wind threat and very heavy downpours and potential for localized flash flooding. And finally, that takes me to our climate change discussion real fast. And I'll get to all your questions. I know that they're flying out there. I will be reaching out to all of them. Outstanding questions out there, so we're definitely going to hit that. I want to talk about this article because there's a lot of stuff going on out there about climate change, and I will get to it each week. But I don't want to overwhelm you with a lot of stuff going on. But I found this really interesting. Attribution of 2020 hurricane season extreme rainfall to human-induced climate change. So the question is, and I know you guys are already going to ask this, and I already got this on Twitter. Hey, how are you going to compare that to 100,000 years ago? Okay, well, first of all, let's say 1,000,000 years ago. Okay, 1,000,000 years ago, we had a warmer natural climate. And I say natural in terms that the only things that were influencing it was, natural evolution of the climate in terms of our solar system and volcanic activity and the way that the seas evolved in terms of the different currents, all that stuff. Dinosaurs and early man was not, driving SUVs and stuff. Okay, so that was clearly driven by natural changes. And with those natural changes, with a warmer environment, you also had higher precipitable water rates. So the precipitable water values enhanced even 6,000 years ago, whatever, all right? It leads to higher rainfall rates. So this is a very simple equation. So we've been talking about for quite some time, where I've been steadfast in saying, as someone I hope that you trust, as saying, like, look, I don't buy into the idea of talking about climate change in terms of temperatures, because recording a high temperature, a record high temperature, and saying climate change is very dangerous, because you have impacts like the urban heat island effect, and you have, in some cases, poor temperature recording. You have some cases where the thermometer is placed in the wrong location. So there's all sorts of error involved there. And so it can lead to a lot of questions and a lot of uncertainties. Some of those questions are very fair. But precipitable water value is a very simple, very stable equation. And it basically is based on the heights of the atmosphere and how much moisture the atmosphere can hold. And the warmer the atmosphere, the more moisture you can hold. And you can test this very easily. Check out the difference between if you take a cold shower and how much moisture ends up on your mirror, and when you take a hot shower. There's a difference. Okay? And it's really, really important to see this in live action. So this is an experiment you could do on your own, where you could rate the differences of moisture being able to build on your mirror in a situation where you have the door open with dry air coming in, door closed, cold shower, door open with a hot shower, door closed with a hot shower. And take a look at the different levels in which moisture can build up on your mirror. Now, the mirror is a great example of a cloud. So the more moisture that you can build onto your cloud, within your cloud, the more it can precipitate, and the higher the rate will be when you're having rainfall. So what these guys did in this study is say, okay, we're going to go based on the idea of the waters are warmer. We have these observations of the tropical systems producing a higher rainfall rate, and they brought that back to, well, look, the precipitable water values were enhanced in every one of these storms, more so than what we were recording 30 years ago. And you could put that whole measurement back through time. And although the data as you move towards the 1800s, of course, is questionable, you could still get a general idea of what we're looking at and what we're dealing with in rainfall rates. So, look, I don't have a time machine. Even if I did, it doesn't work like Back to the Future. I would just come back to a different timeline. So you can't really do that. So what you have to do, you have to take what we know about physics in the atmosphere and what we know about the way that moisture works in the atmosphere, and then compare that to the hurricanes that we're seeing now. And there are several factors to consider. Obviously, one of them is that we have much better ways of detecting and measuring the strength of hurricanes. So there's a good potential that we saw more Category 5 hurricanes than what we realized back in the 50s, 60s, 70s, 80s, and so on. Totally a fair point. But it doesn't change the fact that our rainfall rates are increasing. And the increase of rainfall rates would make sense with the increase of temperature in the 500 millibar to 850 millibar level, which is separated from the urban heat island effect that you would get from the surface, where you could always get those insane high temperatures and record high temperatures, which I think is an illegitimate way to talk about climate. So these rainfall rates, to me, is a better way of explaining what's going on with climate and how it's evolving and why it's important to consider. So that's why I definitely say check out the article here at nature.com. In fact, I'll put it into my Twitter feed after this chat, and you guys can go read it, or you can just Google attribution of 2020 hurricane season. Don't go to the media, like like CNN or any of those, because they really don't give you the actual study. If you go to nature.com, they actually give you the actual study, and you could read all of it. You could take a look at their measurements. What I really like about this study is that you could actually take the data that they actually used, and you could do it yourself, so you could see if there were any errors involved, or if there's something like, hey, this doesn't seem to make sense, and you can reach out to the author politely and ask them about what you might have found and how it contributes to the study overall. So I definitely invite you to check that out. But it's a very interesting study, and one which I think does a good job. It even does a good job of picking up the AMO circulation here and knocking this down, which I'm happy to see, because there are some studies where it tries to max this and tries to dissipate it, and I think that then it makes the study illegitimate. So the fact that they're trying to show here the AMO influence here, the negative AMO influence here, is a really, really good sign in terms of basically recognizing the natural influences of the climate and the unnatural influences of the climate and how it all evolves. So now, with all that, I will put up the radar and I will answer your questions. We have a lot, of course, in the premium chat. We have a couple good ones here in the YouTube chat, so we'll definitely check that out. So first, of course, we work on the premium chat and answer all of your questions. I picked the best ones out of YouTube, as you know. Let's see here. And let's see here. Okay. Card notes first that Climate Signal is a hyperpartisan advocacy group, notwithstanding with their claims of being nonpartisan. I can't help what other people do, okay? I'm a scientist at heart, and I question everything. So much so that I was a real handful in my CCD class around this time of year when we were talking about like Noah Ark and this and that, and I was like, well, how do they not eat? How do they not eat each other? And how did you get all these specimens in caves? And where are these dinosaurs? And what about the T-Rex and all that stuff? I am a scientist to the core. So I'm not good at politics because I'm very blunt. Like if it doesn't have the data, I don't care about your political philosophy one way or the other. I just tell you what I'm seeing and what the data is. And when climate change was first being discussed when I was in college, I had a lot of questions. I was skeptical of like the worst case scenarios because they came out to me like as if it was a sci-fi channel. And I was kind of right in that respect, that they were kind of going overboard in some of these statements that, like, by the year 2000, New York City would be underwater. I'm like, well, it doesn't really work like that in these studies. And you have to assume that all ice on the planet Earth is going to melt away. And that typically doesn't work like that. And even in those environments, you disrupt the sea surface currents of the Gulf Stream, for example, which would lead to a rapid cooling over North America, which would then allow ice to rebuild. So I never was gung-ho about the worst case scenarios. But just basic physics and basic chemistry, if you introduce a gas into the atmosphere, you fundamentally change the evolution of the atmosphere. That's basic as you can get. You could test that in a high school chemistry class, okay, without talking about politics and all this stuff. Just basic, okay, just basic stuff. The question is, what is the sensitivity and how do you adjust for it? Okay, so I can't help what other people do. I just tell you what I'm seeing and what I think. The CME from the dead sunspot was pretty amazing. I don't recall that ever happening before. So much about the sun and solar activity we still don't know. Absolutely, we are learning so much about the sun just the past 3 years, and they've launched a couple of new satellites that we're going to learn even more. And the stuff that we're seeing on the surface of the sun, in some cases, are fundamentally changing the way that we study and look at gravity of the sun and the gravity fields and the sunspots and how everything's evolving and what we previously thought about solar minimums and solar grand evolution, even grand minimums, everything. It's a very, very fluid, very exciting field. If you're interested in the sun, if you're interested in studying that, man, you'll have a job for life doing that, because there's so much stuff that we are learning about that we still don't know. We still are trying to get a better idea on just the inner dynamics of the sun and how it impacts our atmosphere, the other atmospheres of planets. So there's so much, and it's really exciting. I like using spaceweather.com because it has a lot of great little information, but definitely check out NASA. There's a lot of stuff that we're learning, and it's really exciting. There's a lot of stuff that you have to have an open mind, and you also have to add this involved in terms of climate and how it impacts the atmosphere. Okay, just you don't want to be locked in saying it only is this, it's only this theory, and this theory is the only thing that works. And if you put it in your model data in studying the climate and not give yourself the ability to consider different variables or the potential that some variables will change, then you kind of miss the boat in terms of understanding climate dynamics and understanding how the atmosphere works. So always keep an open mind. Okay, don't ever lock yourself into ideology. Always say, well, what if? And what if something does change? How does that impact? And keep that wonder, because then that's how you become a better scientist. Do you see the news, the massive comet, like how they don't explain how or why the comet will slingshot away from the inner solar system before it gets past Saturn? I honestly have not been paying attention to the massive comet, but I'll certainly check it out for next week and see what we can find out about it. That's more of an astrology type thing, astronomy type thing. This is what I get for doing this after 8 o'clock. But astronomy, which is I'm not really an expert on, but definitely it's a very interesting. It has to do with a lot in terms of the way that the planets are moving in relation to the comet and how that impacts the gravitational pull. Compare that to the sun and how that all evolves. A lot more complicated than I would want to explain, and I don't want to like act like as if I'm an expert in that realm, because there's a lot of great guys on YouTube, not only YouTube but also on Twitter that I follow that will do a much better job. So definitely, if you just type in on Twitter like solar or NASA, there's a ton of great followers out there that are following this stuff. Any sign of where ozone pockets will form this spring and summer? I recall from the last couple of summers, these pockets had a big impact. Not yet, a little bit too early. I am noticing in the evolution of colder dynamics around the mid-latitudes, especially around North America. And I am noticing that we're seeing pockets focused over the Rockies and over the northern Atlantic. It's a little too early to say whether those are sustained or not. I kind of want to wait a couple weeks to make that claim because I want to see how the ozone destruction plays out. But this would suggest that we better keep an eye on the potential for backdoor cold fronts. Is it surprising that the second La Nina in the double dip is lasting longer and, if anything, getting stronger? Is it looking like there is a real chance of a repeat of a mid-1970s? We had some nasty winters come out of that La Nina as well. This La Nina is not stronger than the last one. At least I don't think so, based on the data I saw. But I tell you what, there's a way to check that out. We'll go to... Nope, not that one. Let's see here. I'm pretty sure I had the data here a second ago. I know where to go. Let's go look at the real-time data. And let's see. Scroll down. Here we are. Okay, so our last La Nina was stronger. It got up to minus 1.3 and hung around to around minus 1. And that went from basically around July and went all the way into roughly June. This one started in January and it did not get as strong. And it's pretty much on par to what we saw last year right now. But it's expected to, again, kind of linger on through June, possibly in the summer. I think we end up with a weak La Nina or cold neutral environment as we head towards fall. Very similar to what we saw with the previous one. But it certainly isn't stronger than the first one. It's a bit weaker, as you would normally expect it. The last one was a moderate. Whether it could become something similar to what we saw in the 1970s, it's certainly a possibility. The subsurface environment, which we could pull up right here. 1 second. Here we are. The subsurface environment would support a sustained La Nina at the very least through the summer. If this continues through the fall, it's certainly something to keep an eye on. What I would look for in terms of a collapse, if I start seeing colder water down here and warmer water right here, then we could start to talk about changes. Or if we start to see this whole environment moderate and you end up with a very stabilized thermal gradient, then that would also suggest the potential for a weakening La Nina or a neutral environment. Right now, based on the data we have, La Nina is here to stay. Whether it reaches 1970s level, I don't know yet, but it's definitely on the table. A negative AMO appears to be stronger. Am I looking at this right? Let's see here. Here we are. It's very close to being on par to last year, but it's interesting to see that I think that it's more robust in the northern Atlantic than it was last time. Around Africa is pretty much where we were around this time of year last year. But this aspect here is colder than last year. Now, what's interesting is I would like to get salinity reports to see whether or not this is influenced from fresh water, from any type of melting icebergs up here, or if this is just part of the general evolution of the negative AMO. Okay, part of the negative AMO feature is you end up with very warm waters over the Western Atlantic and in the Gulf of Mexico, and we're starting to see that also play out. And so if I was looking for tropical development right now, based on this data, I would keep a very careful eye around the Bahamas, the East Coast, and especially around the Gulf Coast. And then you throw in the La Nina influence with a ridge most likely around here, then you start to really get concerned about the Gulf Coast here, because then you could get storms just track right up into the central and eastern Gulf Coast, possibly even the western Gulf Coast. So certainly something to just keep an eye on, and we'll continue to study that as we move forward. How common are double dip La Ninas? They're not really that common. Usually you get to swing from La Nina, neutral, El Nino, back to La Nina, over to El Nino, and back and forth. So getting a double dip, and in this case a triple dip, which we're not there yet, but if we did, those are rare events, and very interesting events at that. Looking at Earth New School, the area of cold air from 700 millibars and below is rapidly shrinking. You would expect that during spring. I'd be very concerned if it wasn't, because then that means I'd have to still deal with snow, and I'm not ready for snow because it's baseball season and my Mets are doing well. So don't snow on my parade, which is to be expected as we hit to summer. But 500 millibars and 250 millibars are very cold. Huge difference. Yes, that's part of the whole stratospheric influence I was talking about. That colder air, again, let me go back to here. You're seeing this. This is the influence of that. And so that leads to that instability in the atmosphere that we were talking about, which opens up the potential for some really dynamic thunderstorms, not only for our neck of the woods, but back through the plains. I think this is going to be, unfortunately, a very, very dangerous year for tornadoes and hail this year from these thunderstorms, especially in the plains and the Tennessee River Valley. So basically, once the cap breaks and surface air is able to lift, chance of severe thunderstorms will increase. On average, yes. Looks like a real sharp cutoff of the moisture with a lot of dry air behind the front. Yes, that's definitely Friday. As a result, Friday, and for you Met fans, absolutely beautiful for opening day. So it's going to be beautiful because you have relative humidity at like 700 millibars, around 10%. So plenty of sunny skies. 6,000 years ago, the northern hemisphere overall and the northern polar regions in particular were far warmer. Yes, absolutely. Life thrived. Absolutely. Let me put this to you like this. Okay. If you have a gradual warming, the ecosystem overall will thrive. You have more CO2, you have more plants are able to grow, you have more adaptation with different animals and different organisms. The key word here is slow. Every time you have a rapid change, like via a comet or a volcanic eruption or something of that nature, life doesn't do so well, because adaptation takes time and rapid change does not give you that potential. The whole problem here with man-made climate change is not so much the warming. Warming itself is not bad. I mean, humankind actually flourishes in a warmer environment. The problem is the rapid change and the lack of ability to adapt. I mean, let's be honest here. Let's just look at government in general, okay? They can't adapt to anything. It takes them forever to do anything right. The general population takes forever to adjust to changes, okay? So when you're talking about rapid change in environment, you're talking about rapid changes in where we can grow our food, how we grow our food, how we deal with the waterways, how we deal with development of houses. So rapid change is very bad for everyone involved. So it's not so much the warming involved, it's more that the rapid change, whether it's rapid warming or rapid cooling, is very bad in general for pretty much all organisms. And that's always been the case. And that's been the concern, okay? That's the scientific concern, if you actually read the actual studies and not just watch it on the news. Water itself is hotter in the shower scenario. Doesn't it point to ocean temperatures as being a factor of not a driver for precipitable water values? Absolutely. Oh, no. Let me get this. Let me be very clear about this. The driver of enhanced precipitable water values starts off first with warmer oceans. Warmer oceans are driven by the ability for CO2 to trap and enhance the whole greenhouse effect. The greenhouse effect enhances the hold of the water. The connection and the evolution between your warmer ocean waters and that influence in the lower troposphere, let's say from 1,000 millibars on the surface to about 850 millibars, and that layer there, is all driven by what's happening in the lower troposphere and the interaction in the oceans. Now, you combine that with atmospheric influence, atmospheric interaction, and that's where you get your precipitable water values driven. It's not going to be coming from the Arctic, it's going to come from the oceans. So you combine all those factors, and you look at the fact that you have warmer ocean waters on average, even in La Nina events, you end up with that evolution where you're able to hold more water in the atmosphere because of the 500 millibar heights being higher, and you enhance your air temperatures, combine that with the warmer water, so you have bathwater type temperatures, and that introduces more low-level dynamic and mesoscale evolution of your interaction between the boundary layers of the atmosphere and the ocean. It all combines and works, and that's how you end up with these higher levels. So it's all working together. It's not just one thing, it's all this huge process. All this talk about hurricanes has been interested in your early thoughts for us for this tropical season. Feel direct impacts in our area or more remnant/indirect impacts? I'm not sure about impacts yet. I'm still working on that because it depends on how the 500 millibar pattern develops. But I am right now fairly confident of above normal season, with or without the subtropical nonsense that we still deal with. I definitely expect an above normal season. And I expect it to be focused around the Bahamas and the Gulf of Mexico. As far as whether it impacts us, typically with an above average season, at the very least you have indirect influences from, let's say, remnant storms producing heavy rain and whatnot. So that's certainly a factor we're going to be keeping an eye on. But there's still a lot I'm still working on in terms of getting the details. Okay, now let's take a look at what's going on in YouTube here. Wow, it's already 8:42. Good evening, Mark. Let's see here. What are the risks for thunderstorms for southern New Jersey? Okay, I don't see there being much in the way of tornado threats or anything in that case for southern New Jersey. Definitely around the 4 to 8 p.m. hours, depending where you are in southern New Jersey, I definitely expect the potential for some heavy downpours, occasional lightning, but I think your more severe aspects of these thunderstorms are going to be further north towards extreme northern New Jersey and the Hudson River Valley and the Catskills. Is a severe weather pattern setting up for us in May? I think the severe weather pattern more so is focused towards the Ohio River Valley and the Eastern Great Lakes, but we're more likely to see an increase in severe weather activity in May. That is for sure. But nothing that's like that stands out to me as saying like, wow, this is going to be really bad severe weather for us. I think that's further west. I think we see more of a byproduct of that. One thing to really keep an eye on is the influence and the interaction of the maritime air masses and backdoor cold fronts, especially with upper level lows around the Canadian Maritimes, which could lead to some pretty dynamic heavy rainfall events and a heck of a thermal gradient, which we've already seen this year, setting up for the region in general. And I would say that this isn't the Central Plains where you have a sustained severe weather outbreak for months. If you want to see that, you are living in the wrong area. You want to go to the southeast, Mississippi River Valley, Southern Plains, Central Plains. And the reason why is because the orographic environment is set up for that. and you have a better clash with tropical air masses from the Gulf of Mexico, polar air masses coming off of the Rockies and northern plains, and dynamics and shortwave dynamics coming out of the desert Southwest via either the polar jet stream or the subtropical jet stream, especially with dry lines over the southern plains. But you typically don't get sustained severe weather patterns here. You get waves, and you certainly get some periods, but you don't get day after day, week after week, that type of setup. That's more down towards the south. Let's see here. I will keep an eye on to see if we get any more questions from YouTube. Definitely some great questions.
Yeah, what's on there?
I do. Oh, well, let me refresh YouTube here. And let's see here. For some reason, YouTube's being silly. Okay. Yeah. All right. Yep. That's what I got pretty much. I got them all answered then. Okay. Let me go back here, back to the live chat. Do you see the Southeast Ridge remaining firmly in place through the spring and summer? Do you see it being pushed back and forth? It naturally gets pushed back and forth depending on what's happening in the polar jet stream, but I think it's going to be a constant theme throughout the spring and summer. Not sure about the fall yet because that depends on what happens with La Nina. What do you expect weather-wise for Easter Sunday? Any rain, and if so, timing? Right now, in fact, here, let me just pull up the latest model guidance here on this. Honestly, I'm not expecting much in a way in terms of Easter, in terms of impacts. We got a lot of dry air in place for Saturday. Let me pull up the precipitable water values for this. In fact, here, I'll just jump right to the data here. Sunday, in general, I expected the potential for showers on Sunday morning, just in time for the Easter Bunny. But I don't think the bunny will get too wet here, as you have a nice dry environment setting up by the time we get to Easter Sunday afternoon. So there's our cold front coming through on Saturday night. And by Sunday morning, we start to dry out. And really, much of the day on Sunday looks to be pretty dry. So overall, Sunday afternoon, I think you're going to end up with dry conditions overall. Can't rule out an isolated shower with some of these troughs hanging around, but not a washout or anything. So if any outdoor plans, just have a little umbrella handy with you. What time do you expect the heavy thunderstorms in New York City? Again, I kind of like an idea between 4 to 8 around that time period, with showers and thunderstorms being a threat. So, of course, right around the rush hour. And what is summer looking like temperature-wise? I will have a complete analysis on that and a public discussion on the summer in terms of anomalies in a couple weeks. Still working on that overall. But typically, La Niñas increase the potential for high levels of humidity. So I definitely like a humid summer. And I like above normal temperatures. I just don't know the degree yet. Because I'm still working on some of the data and comparing other previous years and measuring that compared to what we're seeing now and how that all evolves. Outstanding questions. And while I'm waiting for our next questions coming out, let me go take a look at the surface. And hey, by the way, how do you guys liking the baseball season so far? Right? I personally have been very happy with it as being a Met fan. Very happy indeed. Let's see here. Let me refresh this. We're starting to see our showers working already. Pretty good. And you're seeing the warm air transport taking place very nicely. Overall, the environment, I'm not seeing anything that stands out as anything that would be different from what's being forecasted. Let's see if there's any changes in the... Yeah, you see what's going to happen. Let me zoom out here. You see this feature here? This is going to separate us in terms of the severe weather potential. This feature here is going to get focused towards South Carolina, Virginia, North Carolina, this whole area right here. So that's where this jet streak ends up. And then you have your influence of the upper level low and divergence and diffluence around, let's say, Syracuse, Oswego, northern New York, Maine, Vermont, those areas, right? We're kind of caught in between. And so while I said your best potential for severe weather is going to be in the Hudson River Valley, we're going to be under just a weaker environment overall in terms of divergence and diffluence. So I really like that idea with our thunderstorm potential. It shows up nicely here as well. So thus far, I'm not seeing anything that stands out that makes me say, things should change, or maybe there's a difference in the forecast. So far, everything's pretty much aligned to what it should be expected for this thunderstorm event. Let's see. Okay. Are you going to forecast for the new football league? There's another one? How many new football leagues are there? Are we talking about soccer, or are we actually talking about football? Because I get confused these days.
The XFL again.
Again?
No, I don't know. I'm saying, are they trying to do that again?
I thought, isn't The Rock trying to do that? I think I saw that somewhere where they're like doing like an experimental league with the NFL. Honestly, probably not. I mean, the USFL. What in the heck is that? Okay, so no. The reason why is that I just don't. I have to sleep at some point, guys. I don't have time for it. I like baseball. The Jersey Generals. Wow. They brought back the USFL and the Jersey. Hey, look, that's great. But no, I probably won't. I probably will just stick to baseball right now, and that's pretty much it. Let's see. I'm tired of this cold. It's so annoying. Yeah, it's annoying to forecast for. It is not fun to see in the model down like, hey, it could snow. I'm like, no, go away. Go to North Dakota where you belong. Leave me alone. Go to Canada. Go to North Pole and hang out there. Leave me alone. So yeah, I feel you. Cold is annoying, very much so during this time of year. The Yankees were down 3-0, and the Yankees just tied it up. Good for them. Hey, look, I think the Yankees are going to be a very interesting team. I don't think they're going to be a dominant team, but I think they're going to be hanging around, and I think a lot of people are going to be very happy with the fact there's 3 wild cards. So at least gets you a chance to the playoffs. So I think they're going to be a good team. Let's see, we got 8 minutes left, so I'll take in the last questions, and then we'll call it a night. Let's see. For the spring, my focus is the Derby, the Memorial Auto Racing, Triple Bill, whether sporting can stay ahead of, and avoid regulation in the Premier League. Okay. Well, my interest is pretty much baseball, and that's pretty much it. I don't have time to. But hey, look, I think that I think weather's going to be a big impact in a lot of spring sports going forward. Just something to just keep in the back of your mind. Of course, and happy Passover and happy Easter to everyone. And I don't know if I think there's other holidays floating around there too. So wherever you're celebrating over the next couple of days, weeks, whatever, happy to that. Enjoy your feast. As Italian male, I always love feasts. So go for it. Rock out. Have fun. Lots of rain delays. Yeah, I do think that's going to be an issue, especially in the spring months. So that's certainly something to keep an eye on. Yeah. All right. So we'll wrap it up for tonight. Again, thank you for a wonderful chat. Definitely outstanding questions out there. I really appreciate it. And we'll be back next week. Drop me some emails on what you guys want to talk about next week in terms of general topics, and we'll definitely cover them. As for that, I am going to call it a night and head on out. And thank you once again, and as always, Stay safe out there.